Hello everyone, welcome to another video. We have a portable air conditioning unit that only comes out every summer on really hot days because it costs a fortune to use. Taken it out over the recent hot period and it wouldn't work. It would turn on, produce cold air for about 30 seconds, and then the refrigerator compressor stopped, and also noticed the exhaust fan wasn't working. I believe it's the exhaust fan that's causing the problem, because the evaporator at the bottom of the unit is getting too hot and it's just cutting out. So I'll just turn the camera around to show you the motor from the unit, which is this. I've taken it off the unit. I may do a separate video on that, but just to show you the labelling on the motor. So we can see there is wiring for a capacitor which kind of goes across the windings. Capacitor's fine, I've tested that and it's working okay. Then we can see we've got a blue going in, which is the neutral, and we've got a yellow and a red wire, which is the feeds for the motor. I don't know much about motors. I've had to do a little bit of research for this. It's an AC 240 volt motor. Does have some references on here, but couldn't find a part at all apart from one guy who was selling one, which I purchased from eBay. But unfortunately this motor that he sent me had exactly the same issue as mine. So with my very rudimentary knowledge of electrics, this is how I set about testing it. The capacitor wires on this have got different terminals on. They've got angled boots, so I know they're from the capacitors from removing it, and obviously the fact that they go to the capacitor. All of the motor wires, the ones that are listed on the side of it, we've got the blue, red and yellow here. So continuity on the meter, sorry, resistance I'm testing on the meter. I'm going to put the black to the negative of the motor, and I would expect to see some resistance on these wires, but as you can see it's just open circuit, there's no resistance at all. Just out of interest, if I go between the wires, I do get a resistance reading. I've got 117 ohms. So let's just take a look at that circuit again. If I focus on the diagram itself, we can see we've got the blue wire, then goes through the windings. We can just see, hoping you can make it out there, just before the red wire is, it says fuse. So I'm presuming that the fuse is blown in this. With a bit of research, there was some guy from a domestic repair shop that I got off Yale. He said it's a sealed unit, but if you can get into it you might be able to change the fuse. So I did purchase some thermal fuses, and let's see how we get on. It is supposed to be a sealed unit, this motor. We've just got a couple of blind rivets that are holding it together, and it looks as if the two halves of the case do separate. I don't have a drill at the moment, so we're going to have to try a different method to try and get those rivets out. There's only two in it, there's one here, and then an earth strap goes on here when it's in the machine. Okay, the only tools I've got to hand at the moment are a chisel and a hammer. So I'm just going to see if I can get anywhere at all with these. Yeah, that's good. So that's come out okay. It's at least taken that off. Let's try it with the other one as well. a bit more stubborn, but yeah, we've managed to take that one off as well. Let's see if we can. We'll pop this clip off here. That's not substantial enough. There we go, just removed that C-clip off there. Now let's try to prise the two halves together. Prise them apart, sorry. Oh yeah, it's opening up quite easily. And there we go, we're inside the unit. Okay, that looks like a thrust washer. I'm presuming it's come out of the back of the unit. Let's put that over there. And the armature for the motor as well. Those bearings seem okay. And the armature looks okay. Okay, so I can see the windings. There's nothing obvious that is looking like a fuse. We just have a lot of windings in there. Just hoping one of those isn't damaged, because I don't fancy trying to find and repair one of those. See if we can make some room. Oh yeah, there we go. Let's slide that just down and out of the way. Okay, so we can see what we're working with now. So according to the diagram, I'm not sure how well you can see that, the fuse is on the red wire. So the yellow wire links to the red wire after it goes through some more coils. I presume that's a high speed for the fan. It looks like it may have two speeds, or it may be a starter circuit for it. As I say, I know nothing about motors other than what I've read up to do this. I have dealt with DC ones in the past, with this being AC. It's a little bit different. But that fuse is on the red wire. So, I can see the red wire up to there. So I don't think it'll do us any good taking anything there, because there's nothing underneath it. I'm gonna see if I can take away these windings and see if we can find where that red wire connects to the windings. This is string. Not sure what the technical name is for it, but the idea is just to hold everything together, make sure it can't move, make sure none of the windings become loose and interact with any of the moving parts. It is quite brittle. I'm presuming this does get hot, and that could be why. Okay. So just where the cutters are right now, this appears to be the end of the red wire. I could see the wire going in, I can see it coming around to here, and then I can't see anything. So I'm just going to turn you off for a minute. I'm going to try and unpick some of this tape and string and see if we can find what it's connected to. So I've done a bit of digging. I've found the end of the red wire. It's tapped off with what looks like one of the winding wires just here. Coming out of this sheath is very, very thin winding wire, and it looks like it's just wrapped around it and connected to it, but I can't see a fuse anywhere. There is another one behind it. I'm just going to take a look in there. Okay, so I think we've found it just here. I've cut that back. You can see under here we've got a fuse. I'm presuming that's the fuse anyway. So let's just see if we have any continuity, just see if it is that that's actually blown. So again, setting to 2K on the meter. And I'm just going to go onto the points that we can see. Either side of that fuse. Nothing there at all. I think we've found an issue, or at least one of the issues. Now I should be able to see where that goes to. Cut that out and take a look at it. Okay, so I can read from it just 139 degrees C 2A, so I presume that's a 2 amp fuse, which is also going to blow at 139 degrees C. Got to take a look on the internet. Okay, so I'm pretty pleased with that. This channel, you can just see it's bent a little bit there because I made it slightly too long, but I've managed to get the fuse back into this channel all the way around. This paper was over the top of this connector, so as long as I insulate this and re-insulate that, I'm pretty sure that's as good as when I opened it. Alright, so that's not looking pretty, but I don't need it to. I've tied up all the loose ends. The original sort of cotton string binding that was on there is tidied up. I've put the fuse back into its channel so it's completely insulated. That channel's gone tight again around it, so there's no chance of anything touching it. And on the other side, again, I've just tightened up with that tie wrap where it was originally. Just going to test it again with the meter, make sure we've still got continuity and that everything is still working okay. Okay, meter's good. Okay, blue to yellow is good. Blue to red is good. Excellent. So let's take a look at putting it back together. I am going to have to knock out these. That's what's left of the rivets. Let's give that a go now. Don't have any centre punches, so I've got an already damaged screwdriver. Let's use that. Just just holding the back down. That's one out. Let's do the same with this side. And 2 out. So luckily for me, those are chocolate rivets. Chisel went through them quite easily. Right, let's try getting this back together. So in there, there's a little red fibre washer, but also the thrust washer came out of that end as well. So let's pop that back in there. Armature's pretty clean, don't need to clean anything up on that. And the bearings are okay as well. Okay, if we drop that in, armature's in the housing. Have to pull some of this back through. It's looking quite twisted that though. Everything just fell out, so felt washer, thrust washer. Let's just try and feed this back in. Okay. Felt washer, thrust washer. Gonna be easier holding it so that doesn't fall out. And it's gonna sit. Like that. Doesn't want to go in there, why not? Okay. Those tie wraps, stopping it going in. Sitting a little better. There we go. So we're in. The motor does spin freely. That shielding has come down a little bit. Let's see if we can get that back in there. Looks like heat shrink that, but it's not been shrunk. Okay, that's in there. Again, I'm just going to keep testing this to make sure that we've not lost any connectivity in the process. So again, get rid of the capacitor wires with the right angle connectors, and we should have connectivity between blue and yellow, and blue and red and yellow. Okay, that's all checking out good. Right, so we're still working. Everything's as it should be. Let's see what we've got to put this together with. Obviously the heads that were on the rivets are quite short. There isn't a lot of space. The motor goes face down on the machine. These bolts that I'm going to use are quite narrow if we compare the two. So we've got that as the head. So the bolt is still a little bit thicker head-wise. Not a lot we can do about that. It does sit in a recess, so we should be fine. So motor's facing down. We want to put the bolts in from this side. There's one. See if we can clean that edge up a little bit. That's a bit sharp. Just going to use that chisel again on that actually. The sacrificial chisel. There we go. That's much smoother now. Get that other bolt in. Okay. Now I am just going to put a spring washer on these. We don't want them coming apart. When it's fitted in the unit, there is screws that go through both halves of the motor. So these will also be helped by 3 large screws. That's the mounting hardware for the motor itself. Okay, put the body back together. Let's get that tightened up. This is one of the most used tools that I have. It's £15 from Aldi a long time ago, with all sorts of useful tools in there. Let's see what size these are. Okay, so it's 7mm. Just going to hold that side. Get those tightened up. And there we go. Last thing, put this C-clip back on. And that's that, the motor's all back together. Spins freely. Does have play in it from the spring washer. Let's do one final continuity check. Get rid of the capacitor wires. Meter's okay. We've got blue and yellow. We've got blue and red. And we've got red and yellow. I'm just going to close these up slightly. These are looking a bit big from having the meter probes in them. Let's check the capacitor ones as well. Yeah, it's been quite an interesting journey, this one. DC motors, I can sort of get my head around a little bit easier than AC ones. I know it's the same principles. Mechanically, obviously we've not got bushes in here. But yeah, YouTube proved to be invaluable when I was looking at testing, although there wasn't a definitive guide. I was trying to Trying to find something that says in between windings you should have some kind of resistance. I never came across anything definitive for that, but obviously I've just proved it in here just by changing that fuse, that the coils are okay. They will have some resistance on them. The more coils, I'm presuming, is going to give more resistance. Okay, let's go and put it in the machine and see if it works. Okay, this is the AC unit. Turn it on. You can hear the compressor running. Blue lights on, so it should be cooling. Set to 22, but it is much hotter in this room. We do have cold AC air coming out. The exhaust fan at the back was not previously working. That's why the unit was overheating. The evaporator at the bottom, was getting too hot, putting the unit down. The exhaust motor is working now. Yeah, straight away. If I lift that exhaust hose off, obviously hot air is being extracted, going through the evaporator and putting it outside. Okay, so we're still getting ice cold air. Still ice cold, that's so nice. It worked. £6.50 for some fuses. What the time investigating. We've got to the bottom of it again. Just out of interest, this unit has, obviously it has a fan in the top for the actual air movement. That draws air through the condenser, which is at the back of the unit. I think I've got that the right way around. The evaporator is at the bottom of the unit. So the condenser radiator is the one which goes very, very cold. The heat is then transferred in the refrigerant to the bottom, where colder air is drawn through it and the hot air is expired out of the exhaust tube. We're still on now. So it would have turned off by now previously. Couldn't get rid of that exhaust heat, so it just stayed in the evaporator and caused the unit to shut down because it couldn't cool itself. That's working okay. Another project completed. This unit, as I say, does have a fan in the top, which goes across the unit. That's like a long cylinder with fan blades on it, and a separate fan in the bottom for the exhaust. Some of these units have one motor in the middle with a fan on top which does the air, and another fan coming off the bottom for the evaporator. Obviously they're a bit more simple, nothing works at all if that goes. This gives a little bit more control over it. You can hear the compressor stopped now because we've actually reached temperature. It's saying 22. Just underneath that, the little blue light isn't on, so it's not cooling it. It must be 22 degrees in here. If I take the temperature down to cooler than the room, I should hear that compressor. There's the blue light. That compressor should kick in a moment. Although the air's still cool, I wonder if it only comes on when it does need to cool it down. That's still very cold air that's coming out of there. Notice the exhaust fan on this only works when the compressor's running, which does make sense. Obviously it's not generating heat in the evaporator unless the compressor's running, so that does make sense. Let's turn that fan up a little bit. I should start to draw air through it a bit quicker. It's still chilled cold. About 3 years old this year, so it only gets used in summer when it's really, really hot. They are quite expensive to build. I quite like the white noise of it at night. I would leave it on all night. But some people don't like the fact it uses loads of power, and some people think it's noisy. Success with this one. Thanks for watching.